Imagine looking up at the sky in the middle of the day and seeing a comet glowing next to the sun. It sounds almost impossible. Daylight is usually far too bright to see anything in space except the sun and sometimes the moon. Even the brightest stars disappear completely when the sun rises. But astronomers believe that a newly discovered comet, has sometimes nicknamed the Easter Comet, could become bright enough to briefly appear in the daytime sky. If that happens, it would become one of the rarest celestial events people can witness. However, there is a dramatic twist to this story. Before it can shine brightly in our sky, the comet must first survive a dangerous journey directly toward the sun. And many comets that attempt this journey simply do not survive. Some are completely torn apart by the sun's intense heat and gravity. Others explode into clouds of dust before they ever reach their brightest moment. So the real question astronomers are asking right now is simple. Will this comet survive, or will it vanish before we ever get the chance to see it? To understand why this object has captured so much attention, we first need to understand what comets actually are. Comets are often described as cosmic time capsules. Unlike planets, which have changed dramatically over billions of years, many comets have remained almost untouched since the formation of the solar system. About 4.6 billion years ago, when the solar system was still forming, enormous clouds of gas and dust surrounded the young sun. Over time, gravity pulled much of that material together to form planets. But not everything became a planet. Some leftover pieces of ice and rock were pushed to the outer edges of the solar system, where they remained frozen in deep space. These ancient icy objects became the comets we observe today. Most of them spend the majority of their existence in distant regions, such as the Oort cloud or the Kuiper belt, far beyond the orbit of Neptune. Out there, temperatures are so low that the icy materials inside these objects remain completely frozen. For millions, and sometimes even billions of years, these comets drift silently through the darkness. Then something changes. A gravitational disturbance, perhaps from a passing star or the slow pull of giant planets, slightly alters the comet's orbit. Instead of remaining in deep space, the comet begins falling inward toward the sun, and that is when the transformation begins. As the comet approaches the sun, the temperature around it begins to rise. At first, nothing dramatic happens. The comet is still far away, and its frozen surface remains mostly unchanged. But eventually the heat becomes strong enough to start vaporizing the ice inside the comet. When this happens, jets of gas and dust burst outward from the comet's surface. These jets create the glowing cloud around the comet known as the coma. Soon after, something even more spectacular appears. Solar radiation and charged particles streaming from the sun begin pushing the escaping dust away from the comet. This forms the long, glowing tail that stretches millions of kilometers through space. And here is something many people don't realize. A comet's tail always points away from the sun, not behind the comet like the tail of a moving object. This happens because the solar wind constantly pushes the material outward. In fact, many comets actually have two tails. One tail is made of dust particles reflecting sunlight. The other is made of ionized gas glowing under the influence of the solar wind. These tails can stretch for tens of millions of kilometers, creating some of the most beautiful sights in the entire solar system. But the closer a comet gets to the sun, the more violent this process becomes. Heat increases dramatically. The jets of gas grow stronger. The comet begins losing enormous amounts of material every second. And this is exactly the situation facing the newly discovered Easter Comet. Astronomers have calculated that this comet will pass extremely close to the sun. So close, in fact, that it belongs to a category known as sungrazing comets. These are comets that travel dangerously near the sun's surface. Many of them follow similar paths because they are fragments of larger comets that broke apart long ago. When these fragments return to the inner solar system, they often face the same fate. Some survive their close encounter and emerge brighter than ever. Others simply disintegrate under the sun's intense heat. And predicting which outcome will occur is surprisingly difficult. Even with modern telescopes and advanced computer models, astronomers cannot always determine whether a comet will survive its solar encounter. Sometimes a comet appears stable and strong until it suddenly breaks apart just days before reaching its closest point to the sun. Other times, a comet that scientists expected to disappear suddenly becomes spectacularly bright, lighting up the night sky. This uncertainty is part of what makes comets so exciting to observe. Right now, astronomers around the world are carefully monitoring the Easter Comet. Each new observation helps them refine predictions about how bright it might become. If the comet survives its close pass around the sun, there is a possibility, however small, that it could become visible even in daylight. And that would make it one of the most remarkable celestial events of the decade. But to understand just how rare this possibility is, we need to look at the history of the brightest comets humanity has ever seen. Because throughout history, only a handful of comets have ever become bright enough to challenge the brightness of the daytime sky. And the stories behind those comets are just as dramatic as the one unfolding right now. Throughout human history, only a few comets have ever become bright enough to be seen in daylight. One of the most famous examples appeared in the year 1910. It was the legendary Halley's Comet. This comet has been observed by humans for thousands of years. Ancient civilizations recorded its appearance long before modern astronomy existed. Every 76 years, it returns to the inner solar system, becoming visible from Earth as sunlight causes its icy surface to erupt with gas and dust. During its 1910 appearance, Halley's Comet became so bright that people around the world could see its enormous glowing tail stretching across the sky. But even Halley's Comet was not the brightest comet ever recorded. That title belongs to several truly extraordinary visitors. One of the most spectacular was the Great Comet of 1843. This comet was part of a family known as the Creutz sungrazers, comets that travel incredibly close to the sun. As it approached the sun, it suddenly became unbelievably bright. Observers reported seeing it in broad daylight, shining like a bright star near the sun itself. Its tail stretched across nearly half the sky. Another dramatic example appeared in 1965. Astronomers named it Comet Ikiyoseki. This comet passed so close to the sun that many scientists expected it to be completely destroyed. Instead, it briefly became one of the brightest comets of the 20th century. For a short time, observers were able to spot it even during the daytime sky. Events like this are extremely rare. The brightness of a comet depends on several unpredictable factors. The first factor is the size of the comet's nucleus, which is the solid icy core at its center. Some comet nuclei are only a few hundred meters wide. Others can be several kilometers across. A larger nucleus usually means more ice and dust, which can produce a brighter coma and longer tail as the comet approaches the sun. But size is not the only factor. The composition of the comet also matters. Different types of ice vaporize at different temperatures. Water ice, carbon dioxide ice, methane ice, and ammonia ice all react differently as the comet warms up. These materials can produce powerful jets that dramatically increase the comet's brightness. Another important factor is how close the comet gets to the sun. The closer it approaches, the more energy it receives from solar radiation. But that energy can also destroy it. As a comet heats up, the pressure from escaping gases can cause cracks to form in the nucleus. Sometimes these cracks grow rapidly, splitting the comet into multiple fragments. When this happens, the comet can either become much brighter or disappear completely. Astronomers saw a dramatic example of this in 2013 with the comet known as Comet Isen. At first, scientists believed Comet Isen might become one of the brightest comets in decades. Many predicted it would produce an enormous tail visible across the entire sky. But as it approached the sun, something unexpected happened. The comet began to weaken. Its nucleus started breaking apart under the intense heat and gravitational stress. Finally, just hours before reaching its closest approach to the sun, the comet completely disintegrated. Instead of a spectacular celestial display, only a faint cloud of dust remained. This is why astronomers are being cautious about predictions for the Easter comet. Even though it has the potential to become very bright, its fate is still uncertain. The comet will experience extreme temperatures as it dives toward the sun. Near its closest approach, the surface of the comet could heat up to thousands of degrees Celsius. Under those conditions, massive jets of gas could erupt from the nucleus, blasting huge clouds of dust into space. If the comet holds together long enough, this process could make it shine brilliantly in the sky. In the most optimistic scenario, the comet might even become visible in daylight, especially shortly after sunrise or before sunset when the sun is lower in the sky. But if the nucleus breaks apart too early, the comet may never reach that level of brightness. For now, telescopes around the world are carefully watching this icy traveler. Astronomers are using both ground-based observatories and space telescopes to measure its brightness, track its orbit, and study the gases escaping from its surface. Space missions such as the James Webb Space Telescope and the Hubble Space Telescope are capable of studying comets in incredible detail. These instruments allow scientists to analyze the chemical composition of cometary material and better understand how these ancient objects behave near the Sun. And that information is incredibly valuable, because comets are not just beautiful objects in the sky. They are also some of the oldest objects in the entire solar system. The ice and dust inside them have remained largely unchanged, hence the solar system formed more than 4.6 billion years ago. By studying comets, scientists can learn about the conditions that existed when the planets first formed. Some researchers even believe that comets may have played a role in delivering water and organic molecules to early Earth, helping create the conditions necessary for life. In other words, these icy visitors may carry clues about our own origins, which makes the story of the Easter comet even more fascinating. Right now, somewhere in the depths of space, this ancient object is racing toward the Sun. In just a short time, it will experience one of the most extreme environments in the solar system. It may emerge from that fiery encounter brighter than ever, dazzling observers around the world, or it may vanish completely, leaving behind nothing more than a faint cloud of dust drifting through space. For now, all astronomers can do is watch and wait, because sometimes the most spectacular cosmic events are also the most unpredictable. And the fate of this comet will soon reveal whether we are about to witness one of the most remarkable sights in the sky, a comet shining in the middle of the day. If the Easter comet does survive its close encounter with the Sun, astronomers expect something extraordinary to happen. As the comet swings around the Sun and begins traveling back outward through the solar system, it could suddenly brighten dramatically. This happens because the intense heat from the Sun causes enormous amounts of gas and dust to erupt from the comet's surface. These materials reflect sunlight extremely efficiently, creating a glowing cloud around the comet that can grow thousands of kilometers wide. In some cases, the tail that forms behind the comet can stretch tens of millions of kilometers into space. If the comet produces enough dust, that tail could become bright enough to see with the naked eye, even from cities where light pollution usually hides faint celestial objects. But observing a comet close to the Sun presents a serious challenge. Normally, astronomers observe comets in the night sky, far away from the Sun's glare. But sungrazing comets appear very close to the Sun in the sky, making them extremely difficult to see without special equipment. Professional observatories solve this problem by using space-based solar telescopes designed to study the Sun's outer atmosphere. One of the most important instruments for discovering these objects is the SOHO. Since its launch in 1995, SOHO has discovered thousands of comets, many of them belonging to the family of sungrazing comets that pass dangerously close to the Sun. These telescopes use special cameras that block the bright disk of the Sun, allowing astronomers to see faint objects moving nearby. Without instruments like SOHO, many sun-grazing comets would never be detected at all. Another important spacecraft that studies the region near the Sun is the Parker Solar Probe. This remarkable mission travels closer to the Sun than any spacecraft in history, flying directly through the outer layers of the Sun's atmosphere. While its primary mission is to study the solar wind and the Sun's magnetic field, Parker Solar Probe has also captured stunning observations of dust and small particles near the Sun, including the remnants of comets that have been destroyed by solar heat. Observations from spacecraft like these help astronomers understand what happens when comets approach extremely close to the Sun. In many cases, the intense solar radiation begins breaking apart the comet long before it reaches its closest approach. The outer layers of ice vaporize rapidly, weakening the structure of the nucleus. At the same time, powerful tidal forces from the Sun's gravity begin stretching the comet. If the nucleus contains cracks or weak regions, these stresses can cause it to split apart completely. This process is known as tidal fragmentation, and it has destroyed many comets throughout history. But sometimes something very different happens. Instead of breaking apart, the comet holds together long enough to produce an enormous outburst of gas and dust. These sudden eruptions can increase the brightness of a comet by hundreds or even thousands of times in a matter of hours. When that happens, the comet can become one of the brightest objects in the sky. Astronomers call such events cometary outbursts, and they are notoriously difficult to predict. Some comets remain faint and quiet for months, then suddenly explode with activity just days before reaching the Sun. Others appear extremely active early on, only to fade as they approach their closest point to the Sun. The behavior of each comet depends on its internal structure, composition, and history. And because every comet formed under slightly different conditions in the early solar system, each one behaves in its own unique way. The Easter comet is no exception. Right now, scientists are still learning about this object. Its exact size is not yet known, its internal structure remains a mystery, and its composition, like the mixture of ices, dust, and rocky material inside it, is still being studied. Over the coming weeks, astronomers will continue collecting data from telescopes across the world. Each new observation will help them refine their predictions about how bright the comet may become. And the closer the comet gets to the sun, the more dramatic the situation will become, because at some point, the comet will reach a critical moment known as perihelion. Perihelion is the point in an object's orbit where it comes closest to the sun. For sungrazing comets, this moment can determine their ultimate fate. If the nucleus is strong enough, the comet may survive and emerge on the other side of the sun's orbit, producing a spectacular tail visible from Earth. But if the nucleus is too fragile, the comet may break apart completely during perihelion, leaving behind nothing but a cloud of dust slowly spreading through space. Astronomers will be watching that moment very closely, because if the Easter comet survives perihelion and begins moving away from the sun, its brightness could peak shortly afterward. That would be the moment when observers on Earth might finally see it, perhaps even during the daytime sky. For skywatchers, events like this are incredibly exciting. Comets are among the most unpredictable objects in the solar system. Unlike planets, whose motions are perfectly predictable, comets can change dramatically from one day to the next. They can brighten suddenly, they can fragment, they can develop enormous glowing tails that stretch across the entire sky, and sometimes they can completely vanish. That unpredictability is part of what has fascinated humans for thousands of years. Ancient civilizations often viewed comets as mysterious omens or messages from the heavens. Today, we understand them as natural objects formed during the birth of the solar system. But even with modern science, they still retain an element of mystery. Because every comet that enters the inner solar system is a traveler from the distant edges of our cosmic neighborhood. And every one of them carries a story that began billions of years ago. Right now, the Easter comet is approaching the most dangerous part of its journey. Soon it will dive toward the blazing heat of the sun. Whether it survives or not, astronomers will learn something new from the encounter. But if it does survive, people around the world may soon look up at the sky and witness something truly rare, of a comet glowing in the light of day. If that moment comes, if the comet survives its fiery dive and emerges on the other side of the sun, the spectacle could be visible to millions of people across the planet. But spotting a comet in the daytime sky is not as easy as simply looking up. The brightness of Earth's atmosphere scatters sunlight in every direction, washing out almost everything else in the sky. That is why stars disappear when the sun rises. Only the brightest celestial objects can compete with that overwhelming glow. Normally, during the day we can only see the sun itself and sometimes the moon when it is in the right phase. For a comet to be visible in daylight, it must become extraordinarily bright. Astronomers measure brightness using a system called apparent magnitude. In this system, smaller numbers represent brighter objects. The sun, for example, has an apparent magnitude of about 26, making it by far the brightest object in our sky. The full moon has a magnitude of about 12.7. Venus, the brightest planet, can reach around 4.7. Most comets that become visible to the naked eye reach magnitudes somewhere between +1 and 1, which makes them easy to see at night, but completely invisible during the day. For a comet to appear in daylight, it must reach extreme brightness, often brighter than 5 magnitude or even more. Only a handful of comets in recorded history have ever achieved that level of brightness. One example occurred in 2007 with the incredible comet McNaught. When this comet passed close to the sun, it became so bright that observers in parts of the world could briefly see it during the daytime sky. But its true spectacle appeared shortly after sunset. The comet produced one of the most beautiful tails ever photographed, a massive fan of glowing dust stretching across the sky like a cosmic feather. Images of Comet McNaught quickly spread around the world, reminding people that even in the modern age, the sky can still produce breathtaking surprises. Another famous comet appeared in 1997. This was the magnificent comet Hale-Bopp. Unlike many comets that fade quickly, Hale-Bopp remained visible to the naked eye for over 18 months. For weeks it dominated the night sky, with a huge glowing coma and a pair of distinct tails stretching millions of kilometers into space. Although Hale-Bopp was not visible in full daylight, its brightness made it one of the most memorable celestial events of the modern era. These examples show just how unpredictable comets can be. Sometimes they arrive quietly and disappear without much attention. Other times they become global events, capturing the imagination of millions of people around the world. The Easter comet now approaching the Sun could fall anywhere between those two extremes. Right now, astronomers are watching carefully to see how the comet behaves as it continues its journey inward. New images are being taken every night from observatories across the globe. Scientists measure the brightness of the comet, analyze the gases escaping from its surface, and refine calculations of its orbit. Each observation provides a little more information about what might happen next. Space-based telescopes also play an important role. Instruments such as the James Webb Space Telescope are capable of studying the chemical fingerprints of gases released by comets. By analyzing the light from these gases, scientists can determine what types of ices are present inside the comet. These measurements reveal details about where and how the comet formed billions of years ago. Some comets formed in extremely cold regions far from the Sun, while others may have originated closer to the giant planets before being thrown outward by gravitational interactions. Understanding these origins helps scientists piece together the history of the entire solar system. Because comets are not just icy visitors, they are remnants of the era when the planets themselves were forming. In fact, some researchers believe that comets may have played an important role in shaping the early Earth. During the chaotic early history of the solar system, countless comets and asteroids collided with young planets. These impacts may have delivered water, carbon molecules, and other essential ingredients that eventually helped life develop on Earth. If that idea is correct, then every comet we observe today carries a small piece of the story of our own origins, which makes the Easter comet more than just a beautiful object in the sky. It is a messenger from the distant past, a fragment of the ancient cloud of material that once surrounded the newborn Sun. Right now, it is racing toward the most dangerous moment of its journey. Soon it will reach perihelion at the closest point to the Sun in its orbit. At that moment, the fate of the comet will finally be decided. Will it survive the intense heat and gravity of its solar encounter? Will it burst apart in a cloud of dust? Or will it emerge on the other side brighter than anyone expected? Within a short time, astronomers will know the answer. And if the comet survives, the sky may soon offer one of the rarest sights in astronomy, a glowing comet shining in the light of day.